All right, welcome. Let's work 2023 AP Calculus free response number 4. Okay, so the graph of the derivative, this is the one we were all expecting, right? We know what's going to happen. I kind of expect it to be number 3, but it doesn't matter when it appears in the booklet. We're gonna attack this one. We're gonna, at least in my class, we're gonna get a lot of points, I hope. So this is the graph of f prime. Okay, and it consists of 2 line segments and a semicircle, and it's one of those upside-down semicircles, which is a little harder on the geometry front, but I think it's going to be all right. At x equals 6, does f have a maximum, a minimum, or neither? Neither, because f prime's sign didn't change, right? X equals -1 is going to be a maximum because f prime went from positive to negative. X equals 2 is going to correspond to a relative minimum on the graph of f because f prime went from negative to positive. But at x equals 6, there was no sign change, so I'm going to say for, see, I feel like I'm a little zoomed out. It's probably going to be more zoomed in than I can handle, but it'll be all right. So I'm going to say neither. Because f prime of x does not change signs at x equals 6. Okay, great. Let's move on. Okay, on what open intervals, if any, is the graph of f concave down? Okay, well, concave down is where the second derivative is less than 0. So I'd say f double prime is less than 0. Well, any place where the slope of f prime is negative. Okay, so I'm seeing a negative slope here and a negative slope there. So I'm going to say from -2 to 0 and from 4 to 6. So -2 less than x less than 0. It's an open interval. And on, 4 to 6. Okay, this one started off pretty easy. I wonder if it's going to get a little bit more difficult here. Okay, find the value of this limit or show that it does not exist and justify your answer. Okay, so we're expecting L'Hopital's rule here, but I have not worked these problems or even really looked at them besides to just like press print and press record. So let's look at the limit as x approaches 2 of 6f of x minus 3x. And we'll see what happens with that one. Okay, as x approaches 2, they told us f of 2 equals 1. Okay, so that's going to equal 6 times 1 minus 3 times 2, and that equals 0. Okay, if the top's equaling 0, I'm expecting the bottom to equal 0, and we're going to apply L'Hopital's rule. Okay, the limit as x approaches 2 of the denominator is x squared minus 5x plus 6, and that's going to equal 2 squared is 4, minus 5 times 2 is 10, plus 6, that's also equal to 0. So since the limit of the top and the bottom were both 0, I'm going to use L'Hopital's rule. Okay, so now this limit is going to become the limit as x approaches 2 of the ratio of the derivative. So the derivative of 6f of x is 6f prime of x. And the derivative of -3x would be -3. And I'm going to divide by 2x minus 5. Okay. Now I'm going to have to figure out what f prime of 2 is. So I go back to the graph. This is the graph of f prime. F prime of 2 is equal to 0. All right, so I've got 6 times 0 minus 3 divided by 2 times 2 would be 4 minus 5. This is a safe place for us to stop, right? That's the limit. Okay, and we justified our answer by showing that the limit separately went to 0 and then maintaining limit notation on a ratio of derivatives. That's very important. A lot of times people will get the answer right on this, but not get all the points because they're not showing their work properly. Okay, so we're going to find the absolute minimum value of f on the closed interval -2 to 8, and we're going to justify our answer. Okay, so we're going to need to check the endpoints, -2 and 8, and then any critical point as well. All right, so for D, I'm going to say, all right, f of -2. Well, that's going to equal f of 2 plus the integral from 2 back to -2 of f prime. And because this is a backwards integral, I might just go ahead and subtract the integral from -2 to 2 of f prime. Now the integral from -2 to 2 of f prime, that's going to require us to do some geometry. So I'm going to just kind of start off right here. This is a total of 1 unit of area. That's a -1. This triangle here is going to be -2, and that's all I need for -2 to 2. So the integral from -2 to 2 would be 1 minus 1 is 0 minus 2. Okay, so, and what was f of 2 again? Is equal to 1. All right, so I'm going to say that this is equal to 1 minus the integral we determined was -2. And so it's going to be 3. Okay. Then I need to check the other endpoint. F of 8 is going to equal f of 2 plus forward integrating from 2 to 8 on f prime. All right, so I'm going to do the rest of these areas. So this triangle also has an area of 2. And then, all right. Okay, the hatched area here, I'm going to say is the total rectangle's area, so it'd be 8 squares, minus half of a circle, 1/2 pi radius squared. So half of 4 pi is 2 pi, so 8 minus 2 pi it's just that hatched region. Okay? So if I want to integrate from 2 to 8, it'll be 2 plus 8 minus 2 pi, 10 minus 2 pi. So f of 2 is 1, plus the integral we determined was 10 minus 2 pi. And whoops, yeah, it was not fully in view. So I'm going to call that 11 minus 2 pi, which would be like 11 minus 6 is 5, okay, like a little bit less than 5, bigger than 3. And did they ask for the maximum? Or they asked for the minimum, okay, so we can tell that that's bigger than 3. Okay, now I need to consider the critical points. So I'm going to say f prime of x is equal to 0 at x equals -1, 2, and 6. And I know that if you're looking for a minimum, you only really need to be considering x equals 2. But I've graded these types of problems before, okay? And the gymnastics you have to go through to exclude these values, in my opinion, is not worth it and is riskier than just computing the values. So we're going to go and we're going to compute f of -1, f of 2, and f of 6. Luckily for us, they already gave us f of 2 equals 1. F of -1 is going to equal, again, f of 2 plus the integral from 2 back to -1 of f prime. So that'll equal 1 from f of 2 minus this, minus the integral from -1 to 2. That's the integral from -1 to 2. That would be -3. So minus -3, and that's going to equal 2. Yes, okay, so this is definitely a candidate to be the minimum because it's less than 3. Okay. Oh, but 1 is still the least thing I'm seeing around. Okay, hopefully that doesn't end up being it. So f of 6 is going to equal f of 2 plus the integral from 2 to 6 of f prime. And okay, the integral from 2 to 6 is going to be a positive number. Okay, but if this is my free response, I want to get all the credit possible. So I'd say that this is half of the 8 minus 2 pi, so 4 minus pi. So 2 plus 4 minus pi is that integral. So f of 2 is equal to 1 plus 2 plus 4 minus pi. 2 plus 4 minus pi. Okay, and then that's going to be definitely greater than 1. And then so it said find the absolute minimum value of f. On the closed interval -2 to 6 is going to, can't even see what I'm writing, I'm very zoomed in here. It's going to be that 1, because that's the lowest thing I'm seeing between 3, 11 minus 2 pi, 1, 2, and this number, which is clearly bigger than 1. So I'm going to say the minimum value is 1. And then that's my justification. All right, so that's all for the graph of the derivative problem for this year. Thanks for watching.